Okay, the following notes is cross-section, section 7.2, and this is the last lesson of your calculus class. So, we have used disk method, washer method, and shells, and we have found this volume by using a circular cross-section on a solid of revolution. However, you have solids that that are generated by rotating that are not cross-sections of circles, such as triangles, squares, ellipses, etc. So any geometric plane figure can be used as a cross-section. I have posted on our website under today's date a website that can let you explore some different types other than the ones that I'm going to do as an example today, because we're only going to do 3 examples. So, the first example, find the volume of the solid that has a square cross-section perpendicular to the x-axis whose base is bounded by the graph x squared plus y squared equals 9. So what you'll notice on to the right is there's the actual 3D figure. It has a circular base, yet we can't slice it all into circles because what those are there's squares sticking up out of the plane. So and right here I have kind of a visual where you can look inside and see some of those squares. So now we need to pay attention of where the cross-section is. So it's perpendicular to the x-axis. So I'm going to go ahead and draw that anywhere along the plane. This is a perpendicular square shooting out of that base. So if I was there, I would take a piece of paper, put it up against the screen, and show that it's shooting out of that. So this red little line is just one side of one square. So the first thing also to realize is that since I drew this vertical line, I know that I'm going to need things in terms of x. So let's take this equation and let's go ahead and solve for in terms of x. So x squared plus y squared equals 9. Y squared equals 9 minus x squared. Take the square root and you have y equals plus or minus the square root of 9 minus x squared. Now, what we're going to pay attention to, though, is that when we're dealing with a circle, if you were graphing a circle maybe on a non-CAS calculator, what you might do is trick the graphing calculator. In order to graph a circle, since it's not a function, I would graph the top half, then I would graph the bottom half. So the top half of my circle is the positive, where the negative really represents the bottom half of that circle. So if you look at this, my first piece is from here to here. That lands on the function, and that's the positive root. And my second piece is here to here, and it again lands on the function. So a couple of you can probably think about, well, that distance would be double because it's the same. What I'm going to go ahead and do is I'm going to call it, what is the side? What is this side of this one square shooting up? Well, the side is going to be, take your length, and think about this like section 7.1. We have an upper minus a lower. I want to find that length. So my upper would be square root of 9 minus x squared, because it's the positive root, minus negative square root of 9 minus x squared, because that's the bottom part. But the negative turns into plus. And so all this work that I just did, some of you should just realize that the length of this would be 2 of your positive root, 9 minus x squared. So this equals the side. So now that I have found the full length of this, if that is just a whole bunch of slices of squares, you need to think about the cross section here. What's the formula if I have a 3D figure with a whole bunch of squares shooting up? Well, the formula would be volume equals, before we used pi r squared, but this is not a circle, it's a bunch of squares. So what's the area formula for a square? We take the side squared. The area formula for a square is simply s times s. Well, what we've done is we have figured out what this S is. And so we're going to replace it right here. So we have the 2 square root of 9 minus x squared, quantity squared. But we need to think about our limits. Again, we're in terms of x. So this circle, remember if it's x squared plus y squared equals 9, the radius is 3. So this goes from 3 to negative 3 as the base. So I'm actually going to write it as negative 3 to 3. And we pick up our calculators to type this in. So when we take our calculators, negative 3 to 3, I'm going to go ahead and put parentheses, 2 square root of 9 minus x squared, get out of the square root because we want to square that side, and then remember the width of each of those squares is represented by dx. You can hit enter or control enter, the answer is 144. So that's your first example with cross sections. And we're going to do 3. So our first example, the answer ends up being 144. Okay, so make sure you tell the sub to pause the video at any time if I'm going too fast. So we're going to move to the next slide. So at this point, make sure you tell the sub to pause if you need to see anything on this slide. Okay, so the next problem. Find the volume of the solid that has an equilateral triangle cross-section perpendicular to the x-axis whose base is bounded by the graph y equals square root of x and y equals x squared. So what I've done is I've given you the two-dimensional graph, I've shown you some triangles coming out, and then I've also shown you what the 3D figure looks like. I guess when I visualize this 3D figure, if you would keep going, is kind of like a half of a paperweight maybe. I don't know if that helps you get a visual of what's going on. But basically this entire base is occurring in this piece right here, and I have triangles. Again, if I was there in class, I would take a piece of paper and show you that they're shooting out of that. So we have y equals x squared that you guys need to graph on your paper, and I know that this is that part, or sorry, y equals square root of x is that part, and y equals x squared is my other part. And you'll notice I only graphed it to where they intersect because it says it's bounded by those graphs, and that intersection's 1, 1. So let's first come up with the formula. The formula for this, because you have a whole bunch of triangles, is simply going to be the volume. You're going to take the area of the triangles. The issue is I have a situation where I have an equilateral triangle. So if I have an equilateral triangle, you know the side. You know a side of that, because think about this. If it's perpendicular to the x-axis, I'm going to draw one of those sides. So perpendicular to the x-axis, there is my side of my equilateral. So this is what I just drew right here. One of these sides that is shooting out of that picture. So that's a side. So my problem is I really want to do the area of the triangle in terms of my side. Well, only area of triangle formula I know is 1/2 base times height. And I don't have any of those. I have the side. I have enough information to find that side. Well, this is where deriving a different formula might be very useful. And I'm going to give you a hint later today. I'm going to tell you a test question that if you derive the formula before you come to class and know the formula, it's going to make that test question a lot easier. Now, sure, you could derive it during the test, but that's going to take some time and more thought. So what we're going to do is we're going to go ahead and derive the area of an equilateral triangle. And when we do that, we're going to have the formula that we normally think of as 1/2 base times height in terms of side. So we know area equals 1/2 base times height. So this is kind of your side work that we're going to use. I'm going to draw an equilateral triangle, And you guys all remember that equilateral triangle have all sides equal. We also remember that each of the angles are 60. So what I'm going to do is I'm going to use our previous knowledge of 30, 60, 90, and I'm going to split this triangle by drawing my right triangle, and I have 30, 60, 90 triangle. So for my 30, 60, 90 triangle, remember if I split this, I know that this is going to be S over 2, or 1/2 S. My hypotenuse is 2 times that amount, which S over 2 times 2 is S, so that worked. And I want you for a second to think about what is the longest leg of a 30, 60, 90 triangle. Hopefully you told me you multiply the shortest leg by √3. So this yellow piece is going to be S over 2 times √3. So what I'm going to do is I'm going to use the formula that you know, and I'm going to replace the information that I now know about the equilateral triangle. Area equals 1/2 times the base, but the base of this is in terms of S now. So the whole base of that triangle is S times the height of that triangle. We're referring to the yellow. The height of the triangle is S over 2 times √3. Let's go ahead and clean all that up. So 1/2 times another 1/2, since that's in the denominator, would be 1/4. S times S would be S squared. Now I could have saved some time here because √3 times 1/4, I could have wrote this came up with this right away. √3 over 4 equals S squared. So you just derived a formula, and maybe you've done this in geometry even. It's just not a typical one that we would use. You just derived a formula for the area of an equilateral triangle, given a side. So what we're going to do is we're going to go back to that previous sample. Again, tell the sub to pause the video if necessary. We're going to go back to this problem, and we're going to say, well, the area of an equilateral triangle has a formula square root of 3 over 4 side squared. So the only thing I need to know is the side. Well, remember, this red little line represents the side. So I want you to think about this. Do we have a way of finding that length? If I draw this out, the blue graph goes from here to here. We know that. It's called the function. The green graph is on the bottom here. Blue minus green would give you the red. We've done that many, many times. If I was there, I would use my rulers to demonstrate it. So the side is going to be very similar to section 7.1, upper minus lower. So the upper is the blue, which is √x, minus the lower. That represents the side. So we're going to go ahead and put this in. Remember, put it in for the side. So √3 over 4, do you want to leave it here or do you want to move it on the outside? Most of you like constants on the outside, so I'll go ahead and write it there. And then side squared, side squared. So √x minus x squared. dx is my width. So now the last thing I need to do is think about my limits. Remember, this problem is in terms of x because you have that vertical rectangle. So the x limits is 0 to where do they bound? At 1. 0 to 1. Now the last thing that we have is just pick up our calculator to come up with an answer. I'm going to use Control-Enter when I do it. So my limits are 0 to 1. I'm going to go ahead, oh, and I didn't put it first, so I'll go back out and put that in there. So I was having calculator issues there, so I went ahead and fixed it so that you didn't have to wait. Parentheses, square root of x get out of the square root, minus x squared, get out of the parentheses, because we derived the formula was a square. Square root of 3 over 4, side squared. And then in terms of dx, and I'm going to hit Control Enter, and it looks like the volume, which seems very, very small, is 0.056. 0.056. So think about that just for a second. The paperweight, as I was describing, is only here between 0 to 1. And yes, there are triangles shooting out of this, but this is a very small. This is, again, my visual here is like this is the x-axis, this is the y-axis, and it's only going from 0 to 1. So that does kind of make sense that it's a very small volume. So again, that became very useful to know the formula so that I didn't have to mess with trying to figure out the height and trying to figure out the base. We had everything we needed, and that could be an advantage on certain problems on the test. And I'm going to give you the one that it could be the advantage on. Okay, so the last problem for today. Oh, this one is about a paperweight. A mathematician has a paperweight made so that its base is the shape of the region between the x-axis, and one arc of the curve 2 sine of x. So go ahead and give yourself a graph. Make sure you write down the important facts. It's also very important that you write down each cross section is cut perpendicular to the x-axis, is a semicircle. So we have the semicircle that's going to be dealt with this time, whose diameter runs from the x-axis to the curve. Find the volume. So take a second to get all that down that you need to get down. Again, if I go too fast, tell the sub to pause the video. Okay, so I need to draw something. I need to draw that one base, one semicircle. And it says the cross sections cut perpendicular to the x-axis. So if I'm going to do perpendicular, and it says the diameter runs from the x-axis to the curve. So I'm going to draw the x-axis to the curve perpendicular. This line right here that I've just drawn represents one diameter of the semicircle. So it would be like right here. Well, we all know the formula for area of a circle. Since it's a semicircle, you should be thinking about what you need to do. So we'll go ahead and write that down first. Area of a semicircle. And then what we're going to do is add all those semicircles up. In order to do that, that's where integration comes in. So you should probably be thinking this already. Pi r squared divided by 2, or 1/2 pi r squared. So we need to first deal with the diameter, because that was what information was given. But then, because my formula is a radius, we're going to have to deal with the radius. So the diameter of this, again, is this green line. So remember, the diameter is from the curve to the x-axis. Well, you should all be saying it lies on the function. So if it lies on the function, the diameter is simply the function. If you want, you could take this back to section 7.1 and say it's the upper curve minus the lower curve, but the lower curve is just minus 0. Therefore, I would have just said it's the function. But we all know that that's the diameter, radius is half of that, so we need to realize that the radius is 2 sine x over 2. Divide by 2, the radius is sine. You got to be real careful, because you can't say, oh, you're already dividing by a half because of the semicircle formula. It's a semicircle, so you have to cut the area of circle formula in half. And it's a diameter, so you have to cut the radius, or the diameter in half for the radius. So now we're ready. Pi equals, again, we're using this formula right here, 1/2 pi, because that's a constant, radius squared, sine of x squared. And we're going to go for x values. Again, we got a vertical. This goes from 0 to this intersection right here. Well, think about your sine graph. Up, back, down. So what is this intersection? When would that equal 0? Hopefully you remember that would be at pi. So take your calculator, type it in, make sure your calculator is in radian mode. So I'm going to go ahead and do this problem. I'm not quite sure what mode my calculator is in, so we'll just kind of find out. Pi over 2, and again, that was just 1/2 pi. And we have the integration. And we're going to go from 0 to pi. Parentheses, sine of x, get out of that parentheses because that's the angle parentheses, and then square. Now I guess you could get out of that and square that. Let's see if this works in the notation. I'm going to hit Control Enter, and it did. Did you notice actually, I don't know if you got this, it moved my square out. I actually had my square right in here. I thought that was good enough. It decided to move it out, but it read it. It dealt with it. And my calculator was in radian mode, so just please make sure your calculator, you come up with the same answer. So 2.467. So not a huge value. Okay, so here comes the test hint. For your test hint, it would be very beneficial to understand a cross section that has an isosceles triangle, but it's an isosceles right triangle. What's going to happen is you're going to have this isosceles right triangle, and the hypotenuse is going to be the information that you're going to know. So you want to work on trying to find the area formula for an isosceles right triangle in terms of the hypotenuse. If what you're going to have, the information you have, is going to be able just plug in the hypotenuse. Now, you could Google this, you could work together on this, whatever you need, but remember, we already did one today that had to do with an equilateral triangle. The only difference here is I'm dealing with an isosceles right triangle, which is a 45, 45, 90 triangle. That's even another hint, by the way. You just want to get it in terms of h, the hypotenuse. We don't really want the base or, be careful, the height. So hypotenuse is something different. So that's my test hint for you, and I'll discuss that a little bit on Wednesday, but what I'm not going to do is verify for you that yes, you have the right formula. Okay, so this concludes the video tutorial, and I'm looking at about 24 minutes, so maybe depending with pausing, maybe this has been about a 30-minute lesson. The sub has the worksheets. My advice would be also to go back to the previous 9, 9, and 10 that I told you you could skip for now. I guess I said you could skip forever, and if you don't want to go back to those, that's up to you. The volume cross-section worksheet, there are a couple repeats, so I apologize. There's a couple problems that you end up doing that you'll feel like you just did them. So if you get to one of those and you want to skip, that would be fine. You have the rest of the hour to work on the worksheet. Keep in mind, I already gave you the review worksheet, which was a whole bunch of ATP problems, and that's for next class. Test is on at the end of the week. If you were absent last class, make sure you get both worksheets, the review and the kind of all the 7.1, 7.2, 7.3 worksheet. And I will post that online next class. Thank you.